And this is a discussion that's happening on a national level, on a much broader scale. I think that it's the way we're going to be making the most impact on the national level is to retrofit our existing buildings. Next slide. When we make tighter buildings, old buildings leak a lot. The leaky windows bring in fresh air. And to live and learn in buildings, we need fresh air. You all know the experience of getting in a classroom on a hot afternoon and you start falling asleep. Our brain needs lots of oxygen. So when we're designing buildings, we have to bring in fresh air to buildings. And one simple concept that saves energy and that was instituted in the Math and Science Center was the notion of heat recovery ventilation. So what happens is there's a simple system in place that as the waste air is exhausted out of the building and new fresh air is brought in, cold fresh air, the heat is transferred from the old air to the new air and saves a significant amount of energy. Next slide. As an architect, I like to believe that the way we experience space is often impacted significantly by the quality of light in a space. So when we were designing the Math and Science Center, we used very precise kind of high-tech computer modeling tools. This is a piece of a computer model that we used to study the solar impact of the design of the building, how light was going to penetrate the spaces. And so when you look up next time you're in your math or your science classroom at the ceiling and look at the geometry, that wasn't a random aesthetic decision to make the angled or sloped ceilings like that, but came directly out of a computer model studying the light levels in the classrooms and determining how much light would penetrate the spaces. There are a lot of secondary results to that, like reduced lighting requirements and things like that. But the net result is better quality of light in the classrooms, and studies actually show, the physical studies out there that show that better quality of light improves test scores of students. Next slide, please. There is some renewable energy. In talking about green buildings, a lot of people immediately jump to solar panels and windmills and the kind of high-tech side of green building. There's a little bit of that going on the Tabor campus and more exploration. Probably most of you kind of know this, but you can see along the top of the ridge of the Math and Science Center, there is an array of solar photovoltaic panels, creates electricity. It doesn't do a significant portion of the job, but it has an impact on the electrical use at the Math and Science Center. There's additionally a solar water panel system that creates hot water. Most of the hot water needs in the building at the Math and Science Center. We've had ongoing discussions about wind energy at Tabor, and I'd be surprised if at some point we didn't see some kind of wind turbine on the Tabor waterfront, but we're not close to getting there at this point. And there's a lot of interesting discussions going on at a national level. There are actually groups out there that are proposing renting solar panels to a place like Tabor. So that Tabor doesn't have to make the big investment to own them, but actually Tabor leases out their roofs to create solar energy for the common electric pool. Next. I'd like to touch briefly now on the notion of heating and cooling. As we all know, thermal comfort is a subjective thing. We all have different tolerances for heat and cold, as witnessed by the feet on the left, or seeing you guys walk around on a winter day in a t-shirt outside. Everybody has a different standard for what their comfort level is. Most people have an expectation in buildings that their environment is perfect, that they should be able to turn the thermostat and get a perfect comfort level at all times. But what we've learned is that a small adjustment in people's expectations can lead to huge energy savings. And the way this is manifested is in how we design buildings, how we think about buildings. So for example, in designing the HVAC systems at the Math and Science Center, we don't design a system for the coldest day of the year or the hottest day of the year. We actually made the very direct decision to design for the 95th hottest or coolest day, knowing that there might be some discomfort in that small 5% of the days. But we ask you to tolerate that, because the upfront cost to design a perfect building, or a building to meet the needs every day of the year, that incremental cost for that last 5% is huge, both to install the systems and to maintain them. So I ask that you change your mindset as you are uncomfortable in a classroom. Again, we strive for perfection in the buildings, but it's not always achievable. Maybe you have to adjust your expectations a little bit, adjust your clothing, or even relocate the class if it's unreal. Next slide, please.